All right, you guys, welcome back to class. Let's look here what we got going on this week. Okay, so we're on week 9. We are starting to do the interesting things. The first half of the course that we've been doing has just been learning the basics of Python, how to actually do some logic and to do some of the basic structures, like the ifs and the try excepts and the method definition and stuff like that. But now we've got just barely enough skills to actually start doing something useful. And I mean barely, because there's a lot more to Python than we've covered, believe me. But we have enough to actually start doing something. And so for the rest of the semester, the last, 5 weeks or whatever, yeah, we're going to be doing applications, meaning we're going to apply our Python knowledge to data. So we're not going to learn more necessarily about Python programming language. We're just going to learn more about what we can actually do with Python, which I think is the fun part. We've had the vegetables part. Now we're getting to the dessert part, I think. Okay, and so we're going to start off with something a little easy, and this is how do we read data from a file. Okay, so we're going to go over that this week, and along with that, we have a quiz and an assignment and a discussion board. And I just wanted to spend a second to show you the assignment instructions, I don't know if it's very clear. But last week, or last module, we did the Charlson Comorbidity Index program. And in that, I gave you 5 sample patients that you used as a program. You passed them through your methods and did your logic, and you came out with a score and a probability. And so for this week's assignment, you got to keep what you've already done, but instead of having the patients in your program, we're going to be reading the patients out of a text file. And this is the text file right here. And it's the exact same patients that you've done before. They're just in this file, and they're in CSV format. CSV means comma separated values. And so you're going to read these patients in. Each line is a distinct patient. And then you're just going to parse that data out of the file, put it into some sort of structure, or whatever structure your program and methods are expecting you to send it in. Call it in your methods. That's going to output some sort of score and probability. And then you're going to save that score and probability into the file at the end of each patient. And then I just wanted to show you just in case it wasn't obvious, we have the patient ID, comma, the patient's gender, comma, the pregnancy status, comma, their date of birth, comma, their first and last name, comma. And then we have their medications that they're currently taking, comma. And then we have their allergies, whatever they're allergic to, comma. And then we have their diagnoses along with a code. Okay. You can't really tell it here, but if you open it up in some sort of text editor, you'll see that this is one single line. And then the next patient starts on the next line, and it's going to be the exact same format. Okay? So that's the idea of what we're doing. And if you have questions about that assignment, or if it's not making sense, then just shoot me an email or whatever the case may be. And we are meeting, I think around October 17th. I've heard that might conflict with other people's classes. So if we schedule a different time, I'll shoot an announcement out about that. But we are meeting here in a week or two, so just keep that in mind. Okay, and as usual, all the content for this week is right here, and you can just copy and paste this into VS Code, which I have already done. Okay, let me just delete this really quick. Okay, hang on. Okay, so let's get started here on this week's material. And then it's a pretty short week. There's not a lot of stuff here. All right, sorry about that. My dog was barking. Okay. So in our programs up until this point, we've been given our data, or we knew what our data was, and it was sort of just affixed and hard-coded in our application. Things like this, right? We had variables, and we somehow magically knew how old this patient was, right? Or in the case of the last assignment, we had a patient and we just knew all this data about them. In reality, though, we'll never actually know that sort of stuff about a patient or have the data that we need within our application. There's a lot of reasons why, and it's not a good or efficient way to do anyways, even if we could do this. Instead, we got to be flexible and sort of abstract the idea of knowing what data we're working with ahead of time. Instead, it's going to be sort of a mystery to us. As long as we know what format the data is going to be in, it doesn't actually matter to our program that we know the data ahead of time or how much data is there, okay? So as long as we can all agree ahead of time when we're writing the program, how we're getting the data, where it's coming from, and what format it's going to be in, nothing else really matters. And that's what we're going to be doing here. We're going to be reading our patient data from a file. We know what format it's going to be in, which is CSV. And then we have some sort of map to know what's the first item, what's the second item, the third item in those comma separated values in the file. And then we can have our program sort of in an abstract way grab that data, put it into a structure that's going to work, and then we just process it and then have some sort of output. And that's how the real world works. Because, for example, working at Intermountain Healthcare as I do, we process data, and we have, I think, 6 million distinct patients we have in our enterprise data warehouse. There's no way to put that amount of data, it's like terabytes or exabytes of data. We would never want to put that in our applications. And even if we could, it'll be out of date as soon as we do, because it'll be, new data is added all the time, new patients are added all the time. So it doesn't matter. We don't want to know that stuff ahead of time. We want to be flexible and nimble, and we'll just read that data. For this class, I've chosen to have us do it in a file just because it's the easiest one, and I didn't know what everybody's background was. The really standard common ways, though, are a database, something like SQL Server or Oracle, or things of that nature. A database is where you're going to have most of your data, especially like in a clinical data repository, like an Epic or a Cerner. Those things are going to be stored in a database. But I didn't know if you guys would have experience with databases or with how to write SQL queries. It wasn't a prerequisite for this class, and so we're not doing databases, although that's probably the more common way that you would do it in the real world. Another really common way to grab data and to have it be in a specific format are web services. Web services are just addresses you can call, like on the web, and you just tell it what sort of data you're looking for as long as you have access to it, and it'll send it back to you. And when it sends it back to you, it's going to be in typically an XML format, and more recently, I should say, we're starting to move towards this JSON format. XML stands for Extensible Markup Language. It's a really verbose and wordy way of transporting data over the internet and to let you parse and read it within your application. And then there's a newer one called JSON, which stands for JavaScript Object Notation. And that's a lot lean. It's very lean and quick. And the reason these things matter, it's a little bit of an aside, but when you're transmitting data over the internet, you want to make your payload as small as possible, meaning what you're serializing and sending across the wire over the internet. You want it to be as small and as efficient as possible. And XML is not that thing. You can go Google up some XML samples. I don't want to do it here. But you can see there's been many times I've worked with XML, and just the format of it takes a lot more data than the actual data I want to send, because it's very verbose. And JSON is rightly so starting to supplant that, and it's a lot slimmer and neater. And again, you can go Google up these things and see them. So for this class, though, we're going to keep it simple. We're just going to be reading a file, and I've chosen to have it be in CSV format. CSV stands for comma separated values. It's a very easy, standard sort of way of doing things. It happens all over the place. In fact, if you use Microsoft Excel, it has the ability to read and store CSV files. It's very easy. But there are others, not to be derelict, just to let you know that there is TSV, tab separated values. So instead of having like user ID, comma, username, it would be user ID tab, username tab, gender. It's just a character that we're using to delimit the data. It really doesn't matter what that character is. Everyone just needs to agree on it. It could be almost anything. But the idea is you want to use a character that's not very commonly found in the text or in whatever message you're trying to encode. So for example, you probably wouldn't want to use like the letter P to separate things because the P shows up all over the place. Likewise, you probably wouldn't want to use like a $ to separate things because there's a chance the $ will actually show up in the text and that'll cause all sorts of havoc. And there are plenty of times when commas will actually be showing up, and we'll talk about a little bit later how we handle encoding commas that we don't need or mean to be separating data. Talk about that a little bit later. There's also a format called fixed width. This harkens back to the older computer days where each field couldn't be more than 8 characters. I'm thinking of mainframe specifically. You can only use 8 characters for most things, and so they would just say, oh, let's just make everything 8 characters. And if you're only using like 5 or 6 of them, you'll just pad them out with spaces or zeros in the case of numbers. But the point is, you just read 8 characters at a time and then just parse that, and that's how they would do it. And there's another older format called packed decimal. It comes from mainframe. That's what this EBCDIC is. I did a lot of mainframing when I was younger. Anyways, there's a lot of different file formats, and I guess I'm giving files a bad rap here, but they are used quite a bit in the real world today, even though there's newer and better technology. Files are the preferred way of doing several things. I know people I've known who have worked for insurance companies, for examples. They'll have a big folder on their servers where hospitals and doctors or whoever will submit their claims to them in a file format, and they just drop them into that folder. And then the insurance company has software that will go read those files, pull them out, parse them, process the claims and stuff. And that's how they've decided or prefer to receive claims data, sort of thing, is in these files and in specific formats. So they're definitely still used, even though there's better, newer ways. Okay. All right, so I think the easiest way here is we're just going to jump right in and start doing the actual work here. So to open a file or to read a file, Python has this method called open. And you can see from my import statements, I'm not importing anything other than datetime, and that's just for later logic. We're not having to import any other libraries or classes into our Python programs to read files. It's sort of something that comes native with Python. Okay. But we got to do a little bit of prep work on our side to make this happen, right? So before we can actually read our file, we need to have a file that exists. And when we call this open method from Python, it's expecting the file to be in the same folder directory as your Python programs are. That's where it looks first. There are ways to change that to have it go look in like just your C drive or some specific location. I'm not going to talk about that here in this class, but just know that you can point it to any location you want. But I'm just trying to keep it simple for us here in this class. Okay, so we're going to go create a file in the same folder that all of our Python programs are, and we're going to go put this data into it. So let me copy this data. So everything between the triple quotes is the data we need in our file. And then we're going to go create a new file. So come over here to this left-hand side. If you don't see that window, if you see something different, you click up here on the left on the Explorer bar, which is these two little file-looking things. You come to this project. Mine's called Hello Doctor. Yours will probably be called something else. And then you just click New File. And I'm going to call it patients with an s.txt. And then I'm going to paste in that data, those 5 lines of data. And these are the same patients that I had given you for the Charleston comorbidity assignment last module, but I just put it in a different format. I put them in the comma separated value format. And we've already talked about what each of these things are. Okay, so we pasted it, we saved it, close it out. Okay. So now that we've got a file to work with, we can actually start doing it. Oh yeah. I don't know if you guys have seen the triple quotes before. The triple quotes just let you put any text in between it, and it lets you retain the formatting of that text. So it's letting us keep, the reason I'm doing it this way is it's letting me keep the new line characters that you can't see, but that are here at the ends of them. So anyways, that's what the triple quotes are if you've never seen those before. And then this is how the data is laid out, okay? I talked about it a second ago, but just know that the first piece of data is the patient ID, and then we have a comma, and then the gender, and then a comma, the pregnancy comma, and then all of these things. And so I wanted to point out a couple of the things that might need explaining, I guess. The first thing is you might be seeing just some commas like this all in a row. You got an example there, that's 3 of them in a row. You got this one here, it's 2 of them in a row, 2 of them in a row. And that might be confusing to you to see. So I just wanted to explain really quickly. We need to, when we have our data, and we're going to be reading our data, it's extremely important that our data stays in the exact same order and format that our application, our program is expecting it to be, okay? So if you're just following this map right here, right? Our first thing has to be a patient ID, and then we'll have a comma. We have to have gender next and a comma. We can't reorder these things, or our programs won't know what to do. We won't know where to get our information. We won't be processing that data right, okay? Like for example, if I switched allergies and diagnoses, that would break a lot of things in our program, right? Or it could potentially, right? Because for example, our diagnoses also have codes with them. You can see over here, right? So we got COPD and some code with it. We would process that differently than we would an allergy, and we're going to do something different with that data, right? So we can't just go willy-nilly putting things in different orders. They have to be in this order. And we're expecting a certain number of commas to be in place to make that happen. And so the example here on this second one with Matea, this patient, what's after username? Medications. This patient does not have any medications. So if they don't have that data, you just put a comma there, and that's holding that spot. It's reserving that location for medications, right? And then what's the next one? Allergies. So we're saying this patient has no medications and they have no allergies. And so we just put a comma there. Because if we didn't do that, it would look like this. And if it looked like that, then we're going to assume what's after the name? Medications. Then we're going to start assuming that these are medications, right? Because they're not in the right spot that we're expecting them to be in. So we have to put placeholders like that, okay? Just to make sure that the program knows that there's no medications and there's no allergies, okay? So we have to leave placeholders for the missing data that we don't have. And that's what's happening here with those double commas and then the triple commas, right? Okay, hopefully that makes sense. And then the other thing I wanted to point out is we want to have lists on here of things, and we need to find a way to separate those list items. We can't use commas. Commas are already being used at this higher level, okay? So for example, if we had right here, so the very first patient, right, is on Zithromax, and then their allergies are amoxicillin, latex, and narcotics. We need a character to separate those, right? I'm using that tilde, which is the very top left key of your keyboard. But I couldn't use commas, right? I could not use commas to separate all those things, because if I were to do that, they're going to say this one is medications, this one is allergies, and it's going to think that this is a diagnosis, which it's not, right? And then we have all this extra data left over. So the commas are being separated to keep these segments in order. So we have to find some other way to just keep these lists together and to know where they break and end. And it could literally be any character. You want to use a character that's going to be not very likely or highly used. I've chosen the tilde because I've almost never seen it used anywhere. I think it's easy to use. Okay, so now we're saying here's their medications, and then here's their allergies, and it's going to be between comma to comma, right? So here's the comma before, here's the comma after. So all of these are allergies. And now we know there's a character. As long as we all agree on what that character is, we can further break these down into lists of things, right? And so we're doing the same thing here, even a little bit more complicated. This is our diagnoses, and again, it's going to be from comma to comma, or the end of the line in this case. We're using the tilde right here to separate the two. So we're saying syncope is one, and then this caliphylaxis is another one. And then I'm using a colon here, and again, it could be any character, just to separate. Here's the diagnosis name, here's the diagnosis code. And then again, the diagnosis name, colon separating, here's the code. So you see we have a few different layers of things of how we're trying to separate the data, but as long as they're in the same segment and they're on the same line and they're the right order, it should be fine. And then we can just agree later on of what character we want to have separate things. Okay, and that's where standards would come in. And if you've seen HL7, this is pretty similar, like the V3 and the version 3. They do things similar to this all over the place. Okay. So that's what our data is going to look like. And we're going to repeat it for every patient, right? So we got this for each line is going to be a patient, and we're just going to replicate that same pattern for all the data we're trying to read. Okay. We just talked about that. Yep. And it's really important because the side effects are kind of disastrous, right? If we were not using these commas in the right way, they might think that these allergies might be diagnoses. And so what are the outcomes of that? A negative outcome of that would be our program would just crash, right? It would be trying to process diagnoses as allergies. It wouldn't know what to do. And your program could just crash. Or for example, if you put the date of birth in the wrong spot and it was trying to parse, this is the date of birth, the program wouldn't know how to handle that and it would crash the application. So that's one side effect, but an even worse side effect would be if we had incorrect clinical data shown. That's probably about the worst thing that can happen, and that's beaten into us, at least at Intermountain Healthcare. I mean, that's the worst thing that you can do is have incorrect patient data shown in the chart. You don't want stuff from the wrong patient or different sort of segments showing where they shouldn't be, because then ultimately the clinician could make decisions based off what they're seeing, and if they're given the wrong information, that could affect patient care, right? They could give them the wrong doses of medications, or not know that they're allergic to this medication, or perform some procedure that they don't need, and it could result even in death or whatever, right? So it's extremely important that we're keeping all of our data straight. Okay, so let's try it here. Okay, so here's the first line of code we got. I'm gonna put a breakpoint here. There's not really much to see. Get rid of that. Not much to see, but again, we created this text file. You can see it over here on the left. Okay, so what I'm saying here is I'm saying open this file, and if you use the left parenthesis, oops, like that, it's showing you all the parameters that we can do. We're going to open a file. So we give it the file name as a string. I'm calling it patients. I say go open patients.txt. You notice I'm not giving it the path. I'm not saying go to the C drive and this folder. Again, it's just assuming that this file is in the same location of where the Python programs are. Okay. But if you wanted to go to a different location, you'd have to go Google up how to do that. I'm trying to keep it simple here. So we give it the file we're looking for, and we have to give it a mode. That's going to be the second string. You can see right here it's giving you more descriptions about it, these things. So we gave it the file, and then we give it the mode. Again, if you do the comma, it'll tell you right there. So it's telling us what all the mode choices are. And if you don't pass one, it'll default. Okay, so starting down here. So the first mode, and the mode we're using is the R, and that just stands for reading. That means we can't save or write data to that text. We're only reading that text. Okay, we can change the mode to W, which means to write, and specifically means to overwrite that data. So if you use a W, again, we'll talk about this in a minute, it just means erase pretty much all the data in that file and start writing it from scratch. A means start writing it and append it. So whatever's in the file, it's just going to add it to the end of it. And then the X is creating a new file. Okay. And again, oh, here's a better list. There's more. So anyways, so that's all we're doing. We're saying go open this file, read it, and I'm going to store the data in this variable called patients. So I wanted to show you what that looks like. So it's got a breakpoint there. And if I hover over patients, it probably doesn't look like anything that you're familiar with. It's got this file, this text.io wrapper is what we're looking at. It's an object that helps us read it. And so you can see here, here's the name of the file it's going to be reading. It hasn't done it yet. And it's going to, the R means reading, obviously, and then a bunch of other options that we didn't muck around with. Okay. And then the buffer is how it's actually going to go get the data. Okay. So it's not really anything interesting to you yet, but that's what we see when we do it. Oh yeah, I also wanted to point out a couple of modules ago, we talked about the try except blocks. And this would be a really good time to start using that because reading and opening and saving files are all very error prone. Lots of issues can go wrong with that. For example, the file doesn't exist. You don't have security access to that file, or the file is already locked by somebody else. You can't do it, or whatever the case may be. All sorts of issues can happen. So it's really a good idea. I'm not doing any of it here, but it's a really good idea to wrap some of this code in the try except sort of code block patterns that we've seen before. At least in your assignments, it would be a good idea to do. Okay. Okay, so now that we have this little object, this text.io wrapper, we want to go grab the data out of it. And there's a few ways to do that. The easiest, I shouldn't say the easiest, the first way you can do it is read. You can see right here, read. That's going to read the whole file in as one big block. So I called patient.read. It's a method. If I hover over document, here's all the text it read out of the file. And it's all of it. That's the whole thing. And so that's not super useful. It's pretty cool, right? We read the file, we got the text in, now we have access to it within our program. So that's pretty cool. But we want to read the data in a little bit smarter of a way, because by looking at this here, we don't see necessarily how to separate it by patient, right? We want to get one patient at a time, or a small chunk of data at a time. Okay. And we've already agreed on the fact that we thought each patient should get their own line. And so we need to have a way to read one line at a time. Okay, so we've opened that file. We've read it, we stored it into memory. And then the next thing we needed to do, I'll move on to other things, but I just want to make sure we talk about this. You need to close the file. Because what we did, once we've opened it and we've started reading it, when you do that, the computer puts a lock on that file so nobody else can touch that file, even you. Nobody else can use that file. And so you have to make sure you close that file. And once you close it, that releases the lock on it and lets other people use it. And if you don't do that, that file will be uneditable and untouchable for other people. Okay. So you just close the file. So you open the file, you do your actions on it like a read, and then you close it. Pretty straightforward. Another thing to point out here is when you're reading data from a file, it's forward only and it's one time only, which may not seem like a big deal to you, but the point is you cannot jump around. So we've been working with like lists and dictionaries and our sets and arrays and tuples and all that stuff. And on those things, you can jump around all over, right? You can jump to the end, the middle, the beginning, whatever order you want. When you're reading a text file, it's only going to go from the start to the end, and you're only going to do it once. Okay? And that might come into play. I'll show you here in a little bit. it might be really confusing when you're calling read data and you can't go backwards to get something you already did and you've already left it, you didn't store it in memory. And then in that case, what happens is you have to close the file and then you have to start reading it all over again from the beginning. And so you have to keep that in mind when you're writing your code, because you want to do it in as efficient a way as possible, right? You only want to loop through this file and read all the data out one time if you can help it, and do all the processes you need on each line of data you're reading out. Because if you don't do it that way, then what happens is you're going to come into a situation where you're going to have to open and read the file to do one type of processing, and then close that file, and then you have to go again, open that same file, read all that same data again, do different processes on it, and then close it. Then maybe you have a third process where you have to go open that same file, do different stuff after you've read it, and then close it. And so it gets really expensive to read that same file multiple times because you're not writing your code in an efficient way, right? You just want to read it once, not multiple times, I guess is why I'm giving you that information here. Okay, another way we can read our data, you can see here's our general pattern we're following, right? We're going to go open that exact same file again, that patients.txt. We're going to read it with an R. We're going to store it to this variable. It's slightly different. And then we have just the read. Up here we had the read, and then we didn't put anything into the parentheses. Here it's read, and we just put a number in the parentheses. And that's just going to go grab the first however many characters you put in there, 5 in this case, and then hover over it. And sure enough, it's 11251, and you can tell that by, if we hover over the document, these are the first 5 characters right there, and it just pulled those out for us. Okay, so that might be something that's interesting to you. I don't know if it would help us on any of our assignments. I'm just showing you different ways you can read the data. The more useful way is going to be the read line. This one right here on line 129. So again, we're going to go open up a file. It's the same file name. We're going to read it, which is the R. And we're going to store it to this variable name. Okay, so we got it. Now we're going to go do a read line. So we've done reads before. Now it's read line. And all that's going to do is it's going to start at the beginning, and it's going to read all of that data until it finds a line break. And it's going to return you just that. Okay, so if I hover over this variable line, you can see that it's all of the data we had just for Chad. And you can tell there's a line break. It's one of those invisible characters you won't see, but the system knows, and it's a \n. That means new line. So that's how it knew when to stop. So it started reading at the beginning. It goes all the way until it finds this \n, and then it returns it to you right here in this case. And again, we close the file. So each time we open it, we do our processing, and we close it. We don't want to leave that file open any longer than we need to, because other people might be wanting to use it. Okay. So then the question is, all right, that's awesome. We read a line of data. How do we actually, keep reading all that data, right? We don't know how many patients are in there, how many lines are in there. So one way you could do it is something like this. This is obviously not ideal, I guess. So we've read this first line, and then we read the second line, right? So now you can see we have the different patient. But anytime we're duplicating or doing very similar things with our code, it's not very sustainable. It's not really written well, right? And also, how many times are we going to have to do this? We know there's 5 patients in this file. We don't know how many patients or how much data is going to be in all the other files. So this is where we've already got a tool to solve this problem, and that is loops, right? We already know how to loop through things. So we're going to put this in a way that we can loop it. That's going to help us read this data a lot more generically. Okay, so again, we're going to go open up a file, and we're going to read it. We're going to store it into this variable. And again, that's not something that's really useful to us. What is useful, though, is when we try to iterate over this text IO wrapper and put it into the loop form, it knows to go grab each of them out in one line segment at a time. So if I hit F10, it goes out to this text IO wrapper. It returns us one line of data at a time. Okay, and then I can do something with it. In this case, I'm just going to go throw it all into memory, so a list of these patients. So now it grabbed the second patient. This one's Matea. I threw it here into memory. Grab a different patient. This one's Annika. This one is Shirley. And this one is Paul. And I think that's all. And so we read through the whole file. We put the data into memory, and then we close the file. Because now we can just deal with it in memory, right? So now if we hover over this place called data, this is where we're shoving all that stuff into memory. See? And now our application can start making use of this data, and it's in patient by patient rows, which are going to be pretty helpful to us. Okay? Okay. So now that we've got our data, we've read our data, we put it into some sort of structure that we can actually start working with. I got a sore throat, apologize. Now we've got to learn how to break this data up into its discrete fields. That's going to be the next thing. Okay. So we can see that each of these items is patient specific, but we need to break all that data out, right? We need to get at how do we find the third patient's gender or the fifth patient's date of birth or allergies or whatever, right? So we have to find a way to break all that data up into be the discrete useful fields. Okay, so to do that, we're going to need some sort of structure that we can store that data in once we break it up. Now, there's a lot of ways you can do this, and I'll show you a couple. Yeah, I just want to double check. Yeah, so I'm going to show you a couple different ways you can do this. The first one is a dictionary. We've talked about dictionaries before, and all they are key value pairs. And I like using dictionaries, at least to start out with here with you guys, because they're descriptive. It describes what data you're looking at, right? So I'm going to create a patient, a dictionary, and he's holding a dictionary. That's what the curly braces mean. And these are the keys, and then these are going to be the values, right? So I got a patient, just a generic name of something. And for the name key, I don't have anything in there, but I would go grab the first thing or third thing or whatever it is, and I would store it here, right? And then the ID, and then the gender, and then all these things right here, right? So this is going to be a generally, or the structure in general that I'm going to use to store the data that I'm going to go parse out. So let's look at how that would work. So I'm going to go open up that same file. It's in read mode, stored into memory. And then I'm going to go loop through that to get one patient at a time, just like we did up above, right? So we've got a single patient here, right there. So this one's Chad. And now here's a different command that's going to be useful. You're going to want to use this for pretty much all of this stuff. And it's called split. Let's see if it will show us here. Yeah. Oh, cut off the top. Let's try that again. Okay, so with the split, oops, right there. So with the split, all you do is pass it a separator. That's what the SEP means. Right here, it's a delimiter. So you're telling it what character, anytime it finds a character, this delimiter, separator character, it's going to slice that off and put it into a new item in a list. And I'll show you here. It'll make a little bit more sense in a second. Okay, so it's going to go look at my patient data right here. This is the data we have for one patient. And on the split, we're saying split the data up by comma. So anytime it's going to start reading until it sees a comma. And as soon as it finds it, it's going to take all that data right here, pull that off, put it into an item in a list. And it's going to keep reading. And then when it finds the next comma, it's going to stop, grab this data, put it into the next item on the list. And again, it's going to keep doing that for all the commas that it finds. And so let me show you what that output will look like. So we take this patient data, which is a big string full of commas. We call the split method on it, tell it to split up things on commas, and if we hover over it, this is what it returns us now. It's broken everything up anytime it found a comma, right? So now we know the first thing is the ID, the second thing is the gender, the pregnancy status, what have you. And you can see that the amoxicillin, right, these are the allergies, there's still one item, and our diagnoses are still one item. So that's really useful for us, right? Now we can go shove that data into our structure and use it. All right, so we take our split data, we go say grab that first thing, that's the ID, whatever, gender, whatever, and then we got our date of birth, for example, is a string. We need to actually convert that into a date time object. This is some handy code you can just steal from me. You can do it other ways. This is an easy way. But we're going to convert that into a date time so that we can do calculations, right? We'll probably need to figure out what their age is at some point. So we have to know their date of birth to know their age. And so we got to convert it to a date time to do those things. So I did that here. And we're going to go fill in the rest of those things. Okay. So now if we look over here, now we're starting to work with something a little bit pretty cool, right? Pretty easy to handle here. So now for the first patient it read in, it says, okay, here's all the allergies. Here's all the diagnoses. Here's your date of birth. Here's your ID and your name, right? And that's why I like dictionaries, because it's descriptive, right? You can go say, I don't need to know if it's the fifth item. I just need to know it's called medications. Go find those medications. That's what dictionaries do for us. Okay. So it's going to go do that for all 5 of them. And so if I hover over here, I can see all of these are in the exact same sort of format. This one's for Shirley. This one's for Paul. Okay. So now we've read the file. We've opened the file. We've read it. We've parsed it out using the split command. We put it into the structure that's helpful for us. Now we're going to close the file. Okay. Okay, so it's pretty good, but we're still not quite, it's still not quite processable. We can't really compute this data yet because we need to still break up the medications, allergies, and diagnoses because there we go. So they're all still just one big string, right? We need to break those up and to be a list of things, right? Because that's what we're going to need to know. Because we're going to have to loop over those at some point. And if it's in one big string, we can't loop over them very efficiently. Okay, so we're going to do the same thing. This is the exact same code from above with just 1 or 2 differences here. So now we're going to go open up that same file. We're going to read it, store it into memory. Now we're going to go loop over that one line at a time, just like we've been doing. This one's Chad. And again, we know how to split the data. So now we're getting it into the split format. And now when we store it into our dictionary, we're going to do one extra step of work, which is here on lines 2, 18, 19, and 20, right? I added split. So right here, we didn't have any splits. We just had the data 5, 6, and 7. The data 5, 6, and 7. But this time I added a split. This time I told it to split my data anytime it finds one of those tilde characters, because that's what we agreed on, or what I agreed on should be the character we use to separate medications, allergies, and diagnoses. Okay, so we're going to go from this data, right, where we have diagnoses is just one big string, to this data. Let me just process all that. Where we have, oh, I didn't reset it. That's funny. But the point is we're going to have a list of things, right? So now our diagnoses are broken out, right? So now our diagnoses aren't a string. Now they're a list of things. Okay. So we're saying we have dementia is its own item. His code is still there. We could break it out further. I didn't do that for this example, but you could go break it out now off of the colon and separate the code from the actual text. But the ideas are there, and they're in their separate elements, right? So now the one diagnosis gets one list item. And so now you can go do a bunch of loops, right? Because I'm sure your Charleston assignments or whatever assignments you're going to do, you're going to want to be looping over this data to go see if what patients have right here as their diagnoses are going to go match anything that the Charleston logic is looking for. And you're going to go on a loop over that. And you couldn't do that before as a string, but now we put it into the list format using the split command. Okay. So now we have all this fancy data. We've read it to memory. We've parsed it. We put it into a structure that's going to be interesting for our methods, that they can actually use it and process it. Okay. Okay, so now the question is what? Now what are you going to do, right? So I'm just trying to close the loop here on you, on your knowledge here. So we got all this data. It's in a generally good format. The question is, what are we going to do with it? And now all you're going to do is you're just going to go pass it in to the methods that you've called before. Okay. But before we do that, let me show you. I wanted to show you, I'm using a dictionary here, which might be a little bit heavy or clunky for what you want to do. But I want to show you, here's a different way that we can process that data without using a dictionary. I just wanted to give you a separate example. You don't have to do it the way I'm doing it. I'm showing you a different way. So we're reading that same patient. We're storing it into memory, just like we've been doing. We're going to loop over it one at a time. We're going to still split it. But this time I'm just throwing it into a list. I'm still doing the split on the diagnoses, medications, and allergies. Let me get all the way down here to the end. So this time I did it a little bit differently. I'm just making a list of things. So instead of saying right here, it would have said patient ID, patient gender, pregnancy status. Instead it's just numbers, because that's what lists are, right? It's not a dictionary. And again, so now we just have to know the first item is the ID. The sixth item is going to be the other list of, what is this, allergies, and then diagnoses, right? So I'll just show you, this might be a way that resonates more with you. I'm just adding all these items to a list, and then I'm repeating them for the patient. Okay. So if you don't want to use a dictionary, if lists are easier for you to work with or to think about, you can do it this way. Hopefully that makes sense. Okay. So now, back to what I was saying before. The question is, now that you've got all this data and you got it in this format, what are we actually going to do with it? And the idea here is you're going to take this data that we've gotten to memory and you're going to pass it through the methods that you've already written. So it's going to be one of your limiting factors, right? You got to know your code that you wrote, whatever methods you've used for your Charleston or whatever assignment we're talking about. And you got to know what data that method is expecting, right? Is it expecting a list of patients that have things in certain order? Is it expecting a dictionary? Is it expecting just the medications portion? Is that going to be in a list or in a tuple? You got to know what your method that you've already written or that somebody else has written, how is it expecting that data to be passed into it? And then you have to do that. You've got to give it that data in that order, in that format, okay? I showed you an example here of how to do it in just a list. This is an example on how to do it in a dictionary. So you got to get the data out of the file, put it into the format that your method is expecting, and then actually do the work to fill in that data and then send it off to your method. Okay? Okay. And I did want to show you one more thing, a couple more things. We're getting close. We can add data to the end of the file. That's what the A means. So we're going to open up the same file. The A means append. And again, append just means it goes to the end of the file and adds new stuff in there. Okay. Yeah, not a W. Okay. So we have this file called patients. I'm going to add in one new row. And then I'm going to close it and just to go show you what that looks like. Oh, I got to go update it. Dang it. Yeah, let's see. There we go. So we added in the other patient there at the end. Okay. This one hadn't been updated yet. Okay, so that's just showing you how to store data. Okay, so now I just made a quick little fake program to show you how we're going to put it all together. Okay, so we're going to go read the data from the file. We're going to put it into the structure that our methods and programs are expecting. We're going to pass that into our methods. Those are going to do some work. They're going to give us output, and then we're going to save that output back to the file with those calculations in it. Okay. So this is just a fake method. Obviously, that's not how you would calculate the Charleston Comorbidity Index. I also didn't want to just give you guys the answer, so I just made a fake one in case you hadn't already done that assignment. Okay. So here we go. So we're going to go open up the patient.txt file. We're going to put it into read mode, read through it one line at a time, split it out by commas. I'm using lists this time because that's what my method is supposed to be using. Okay, sorry, my dog. Okay. Here we go. So we put it into the same format that we've seen before, right? So these are the numbers 0 through 7 for each patient, one at a time. And now we just pass that into whatever our method is, right? And again, this is where you have to know what your method is expecting. Just because this is how mine is doesn't mean this is how yours was written or will work. You might need dictionaries or tuples or whatever, and your data might have to be in specific order, right? For example, my 0 item is patient ID, and then gender and pregnancy status. Yours might be expecting that to be in the 5th item and the 8th item or whatever, right? So you are assuming you've put it in the right format. You pass it into your method, and then you're going to store the result, okay? So I'm going to hit F11. This is the data we passed into our method, those first 8 items. We do whatever work we're going to do. This is obviously not it. And then we're going to return some results, right? Those results are what's our Charleston score and what's our probability right there, okay? And then in my case here, you don't have to do it this way. I'm appending that data to the patient. So now in addition to what I've had before, those first 7 items, now I have these other 2 items here, right? The probability and the score added to the end. We're going to do that for all the patients. Let me just jump down here to the end and show you. So now all these patients we've processed. All these patients have the calculations at the end. Let's see if any of them are different. No, they don't. They're all the same. They all have the 0 and the 90.5 at the end. Okay. Close that file. And now we want to save that data. And so the question is, we have all that data in memory. How are we going to write that back out to the file? And so for that, we're using a W in this case. And a W, remember, replaces the whole file. The A was appending stuff to the end. The W is just going to replace the whole file with whatever we tell it. So since we have all of our data in memory, we're going to start a brand new file and just write everything out from scratch. Okay, so we're going to go open this new file, just like we've seen before. This time it's in W mode. Now we're going to go loop through all of our patients that we've done before. These are the first 5 patients. I'm going to go grab one at a time. Okay, so it has all that data plus our new calculated data right here at the end, that 0 and that 90.5. It should be different. It should be something real when you do it. And now we just got to go write it out. So we go to write data to a file. Right here, we take this variable where we opened the file with, that patient's 10 in this case, and we say write. So go to that and write. And whatever data we pass it in between those parentheses is what it's going to write. So this has to be done in the right order and has to be done in the right format, meaning we have to have the commas separating things, and we have to have the tildes separating other things. And let me show you that when we get there. Okay, right, so we're going to take the first item, which is just the ID, and then the comma, and then the gender, comma, pregnancy status, comma, date of birth. We got to convert that back to a string. That's what we're doing here. We're stringifying the time. stringifying a time, or we're putting it in a specific format. Okay, and then on these ones, so for the 5th item, let's just do this one, the 6th one here. These are our allergies, amoxicillin, latex, and narcotics. We want to put those into a single string with tildes in between them. And here's a quick way you can do that in Python. You take the character you want, like that, and you do .join, and you give it the actual data, the list data, and it'll do that for us automatically. And then we're adding in the new data here at the end, and we're stringifying it. We're converting it to string, because those are numbers, right? The 0 and the 90.5 are integers. We're going to convert those down to string. And then the most important thing here is we're ending it with a /n. That means we're starting a new line in our file, and that's necessary because we won't be able to read the data back if we don't have that new line there. Okay, so we're going to go through and do that for all 5 of them. Oops. And now if we go look at our patients.txt file, you can come here and find Reveal and Explorer, patients.txt. Now you can see we wrote all that same data out, but we have these calculations here on the end of it. Let me open that up in a better tool. I like Sublime Text a lot because it has the line numbers here on the left-hand side. So you can see we wrote out all that same data in the same format. It put everything commas in there, it put the tildes back in there for us, and it has our new data, our new calculations in it. And that's what the final assignment is going to be. Okay. So that's it. That's all the material we have for this week. And that's how you read, write, and save files. I know it's a really quick one, but there's really not a lot to it. You just need to start practicing. And the most important thing to remember is the format and order of things. And again, put it into the formats and order of things that your method is actually expecting to have it in. And when you do the assignment, I'm going to be using a different file than the one you're working with here for testing, just to truly make sure your application is abstract enough that it doesn't care what data it's reading and you don't have any hard-coded logic about certain things happening. And just like we did on the unit tests, I write a couple of unit tests to actually read your program and to execute it and to see how well it's performing. And then my unit test will let me know what sort of score to give you. So I'm writing software to test software. Okay, so I know there's a lot here, or a lot of weird things, right? But the main things we've learned this week are the open command and the split command. And also this join is slightly different. Probably haven't seen that before. So there's only 3 new commands, and then the rest is just understanding conceptually what we're doing here. And so that might take a little bit of time, is to conceptualize what's happening here. So just play with it, and once you're happy with what you're seeing, then you can start on the next assignment, which is this one.